In 8.3, we focus on multiplying and dividing complex numbers in their trig form. Now you know how to multiply and divide complex numbers in their rectangular form. If I gave you rectangular complex numbers, for example, let's say 2 plus 3i, and I told you to multiply that times 4 minus 7i. Well, if I'm going to multiply these two complex numbers, I would just FOIL. We did that in 8.1. If I'm dividing complex numbers, if I set it up as a quotient, also in 8.1, we talked about the fact that to do this division, find this quotient, you just multiply by 1 in the form of the conjugate of the denominator. So we know how to do that as well. These are very algebraic tasks. When we move to trig form, however, we have some new methods to approach, and they're not difficult. You're gonna be able to pick up on them very quickly. First of all, let's talk about how our arithmetic operations pair up. We know, for example, that multiplication is just repeated addition, right? If I want to give each of my 7 kids 3 cookies, I have a choice. I could either say, okay, I've got 3 cookies for this kid, then 3 cookies for this kid. So I could say 3 plus 3 plus 3 plus 3 7 times, or I could just do 3 times 7. Multiplication is just repeated addition. In the same manner, division is just repeated subtraction. Okay, so multiplication is repeated addition, division is just repeated subtraction. So when I start pairing up operations, I usually pair up multiplication and addition, division with subtraction. That's true with exponents. My rules for exponents, if I have x cubed times x to the 5th, I'm multiplying the bases. What do I do to the exponents? Well, I add them. If I'm dividing the base, I subtract my exponents. X cubed divided by x to the 5th would be x to the negative 2 because I subtract the exponents. The same is true when I get to products and quotients for complex numbers in trig form. My product theorem, if you read through, if I'm trying to multiply together two trig form complex numbers, basically what I do is I see that I have my moduli here, r sub 1 for the first number, r sub 2 for the second. I multiply the moduli together, and then I add the arguments. So this is my CIS theta form, same thing, expanded form, CIS theta form. If I'm trying to multiply these two complex numbers together, I multiply the moduli, add the argument. So I multiply their absolute values, which is those modulus r, that's what that is, the absolute values, and add the arguments. That's how I multiply complex numbers in trig form. Let's practice a little bit. If I want to find the product of these two complex numbers, I'm going to multiply the moduli. So I will have 4 times 5. And then inside I have CIS theta, right? So I have cosine theta plus I sine theta. So I have cosine of, well, my arguments are 120 and 30. So 120 plus 30 plus I sine of 120 plus 30. Well, 4 times 5 is 20. And then I've got cosine of 150, because 120 plus 30 is 150, plus I sine of 150. And I'm told to give the result in rectangular form. This is my trig form. This is the product in trig form. So if I were able to stop in trig form, I'd be done. But I'm not able to stop in trig form. I'm supposed to go to rectangular form. To get from trig form to rectangular form, I just plug in what I know. So if I don't remember this, I go look at my unit circle. 150 is in quadrant 2. It's 30 degrees away from the x-axis, so I use that 30-degree reference angle. Cosine at that reference angle in quadrant 2 is a negative square root 3 over 2. sine at that reference angle in quadrant 2 is a positive 1/2. And then I distribute my value for r so that I have negative 10 square root 3 plus 10i. Since I don't have a radical here, I put the I behind. If I'd had a radical, I would leave the I in front. That's my rectangular form of the product. And I was asked to go to rectangular form. Okay, if you think you've got it, pause the video and do this next example. Okay, so here is what you should have gotten on this second example. Remember, you multiply the moduli, you add the arguments. So you get 6 CIS 180 in trig form, but you're asked for rectangular form. Since you need to go to rectangular form, you take cosine value at 180 and sine value at 180, plug those in and simplify. Okay, let's look at the next page and talk about finding quotients of complex numbers in trig form. When I'm doing quotients, quotient is the answer to a division problem. And remember that we discussed the fact that division pairs with subtraction. So here's my longhand. If I'm trying to divide the first complex number by the second complex number, I divide the moduli and subtract the arguments. And here we are in shorthand, that CIS form. If I'm dividing this first complex number by the second complex number, I divide the moduli and subtract the arguments. Let's go ahead and write that down. We're going to divide the absolute values, that's my moduli, my R values, and I subtract the arguments. Okay. So our first example wants us to find the quotient of 27 CIS 45 degrees divided by 9 CIS negative 180. Now pay attention that my argument in my denominator is negative here. To find this quotient, I'm going to divide the moduli, the R values, and then I'm going to subtract the arguments. So I've got CIS 45 degrees minus a negative 180, which is the same thing as plus 180 degrees, and 45 plus 180, 180, not 18. 45 plus 180 is 225. 27 divided by 9 is 3, so I have 3 CIS 225 degrees. That's my trig form, but I'm not allowed to stop there. I've been told to go put it in rectangular form, so I need to keep going. If you remember what CIS stands for, you can leave it just like that, or you can write it out longhand if you need to and say 3 cosine 225 plus I sine 225 degrees. Don't forget that degree symbol so that it's distinguished from radians. And then I fill in those values. Cosine at 225 is a negative square root 2 over 2. Because we're in quadrant 3, they're both negative. Plus I negative square root 2 over 2. And then I distribute that. And what I get is a negative 3 square root 2 over 2 minus 3 square root 2 over 2i. Notice I can put the I behind because the entire, the coefficient is 3 square root 2 over 2. So there's no way that I can mistakenly stick that I underneath the radical. The radical's in the numerator. The I is down outside. Okay, so once more, I'm going to pause my video. I want you guys to do this next example and then check back to see if you got the same thing I got. Okay, here we go. So I found my quotient by dividing the moduli and then subtracting the arguments so that I know I'm working with an angle of negative 210 degrees. Remember that a negative 210 degrees means I have rotated clockwise instead of counterclockwise. We usually don't think in terms of negative angles, so I want to identify where this angle ends, where the terminal side of that angle falls. And by adding 360 or by doing the rotation, I discover that it's coterminal with 150 degrees. Well, I know how to think about 150 degrees. My cosine and sine function values at 150 in quadrant 2 are negative square root 3 over 2 and 1/2. So this complex rectangular form is negative square root 3 plus I. Okay, we just have a couple more examples of each. We have 2 more product examples and 2 more quotient examples that we want to go through. Let's do the products first, and then we will come back and do the quotients. If you've got this, I encourage you just to pause the video and work through them, and then come back just to do a quick review to make sure that you did it correctly. Remember that multiplication pairs with addition. So over here, also notice that I'm not dealing with special angle values. So when I do this, when I get my solutions, I'm going to have to find approximations. We're going to round everything to 4 decimal places today. I can't remember exactly what my math lab tells you. It may tell you more or less, but we are going to go to 4 decimal places on our approximation. Okay. All right, so to find A, I multiply the moduli. 2.8 times 5.4 is 15.12, 15 and 12 hundredths. And then I add the arguments. So I've got 15.12 CIS, and then my theta value is 113 degrees. Well, this is my trig form. I need the result in rectangular form. So what I'm going to do is I'm going to say, okay, and I may need to write this out in longhand to be able to see it better. I need cosine of 113 degrees plus I sine of 113 degrees. I will just use my calculator to find cosine of 113. Remember that you need to be in degree mode. That makes all the difference right there. So cosine of 113 degrees times 15.12 should come out to be a negative 5.9079. Make sure you round correctly. Plus sine of 113 degrees times 15.12 should give you 13.9180i. Now, why did I include that trailing zero? Because I said 4 decimal places. So I have to have something in that 4th decimal place, even if it's a 0. Let's look at the next one. Same process. Once I have multiplied the moduli, added the arguments, then I use my calculator to distribute that R value, that modulus value inside. Rounding to 2 decimal places. Don't forget to come in and place I at the end of your sine function value, because it's I sine. Because I'm not using radicals here, I goes at the end, not at the beginning. Okay, let's go back up and do our 2 that are in, we're finding quotients. With this first one, to find quotients, I divide the moduli. So 11.37 divided by 3.79 comes out to be 3. And then I'm going to subtract my arguments. Now, when I subtract my arguments, I am going to need a common denominator. My common denominator between 5 pi 6th and pi 4th is going to be 12. So let's go ahead and, well, yeah, we'll just come over here and do this. So to get a common denominator of 12, I need to multiply the first argument by 2 over 2 and the second argument by 3 over 3, which gives me 10 pi 12ths plus 3 pi 12ths. Ah, no, it does not. Minus 3 pi 12ths. There we go. 10 pi 12ths minus 3 pi 12ths. Why am I subtracting here? Well, because I'm dividing, finding a quotient, and division pairs with subtraction, not addition. So my argument for that CIS statement is 7 pi 12ths, which is not degrees, it's radians. So when I go to change this trig form into rectangular form, and I say cosine of 7 pi 12ths plus I sine of 7 pi 12ths, I need to make sure that I've changed my calculator setting to radian mode, because I've been given radians. Now, what quadrant is this going to be in? 7 pi 12ths, 6 pi 12ths would be pi half, so 7 pi 12ths is going to be in quadrant 2, which means my cosine value is going to be negative and my sine function value is going to be positive. If you will just kind of stop and think about where these angles lie, then you won't be surprised, and you can double check yourself and hopefully start making sure that you've got values that make sense. All right, we have one more example. We're doing quotient again, dividing. So my moduli, when I divide, I just get 2. That's simple enough. My arguments I need to subtract, so I'm going to need to say 3 pi fourths minus pi fifth. I need a common denominator. My common denominator is going to need to be 20. So I'm going to multiply this first argument by 5 over 5 and the second one by 4 over 4, which gives me a 15 pi 20ths minus 4 pi 20ths. And remember, I'm subtracting because I'm performing division over here, and division pairs with subtraction. So what I get is 2 CIS 11 pi 20ths, which is my trig form, but I'm asked to answer in rectangular form, so I'm not done. I need to find cosine, multiply it by 2, then find sine at that angle and multiply it by 2. I end up with negative 0.3129 plus 1.975 for I as my complex rectangular form.